right? Is that landscape? Thank you. All right, so good afternoon, everyone. We have three different conditions in here. First, how to determine the xy plane, or what we call Cartesian equation, given the parametric equation in terms of t's for both in here, and also how to do the reverse. How to get the parametric equation given the xy equation. There's one more, how to make a parametric table, values based from t values given. So for here, let's consider answering one of these questions in here. Let's try number 13. Let's try read number 13 in here and see how we can work on this one. Okay, so this is our number 13. Let's read this one first. Jillian, go ahead, please.
For the following exercises, eliminate the parameters to rewrite the parametric equation as using equation.
Thank you, right? So you are given the parametric equation because both x and y are given in terms of t. That's what we're gonna do now is to remove the t, parameter t, to get the Cartesian equation. By the way, Cartesian equation can also be called the xy plane equation. So let's rewrite this in here and see how we can work on this one, okay? So let's put it in here like such. Given, what's our x? X of t is equal to, what did it say? 4 common log of t. And y of t is equal to a linear equation, 3 plus 2t. So as you may notice in here, one is a logarithmic equation, parametric, and the other is a linear equation, 3 plus 2t. So what do we do first? Let's read in there, step number 1. First, step number 1, what do we do? Paola?
Solve for sine t and cosine t from given equations.
We're going to use that one if we have sine t and cosine t. However, this one doesn't have it. That's why we're going to use this one instead, right? We're going to solve for, Viola, let's read this one instead.
Solve for t from given equations.
Okay, so we're going to solve for t first in here from the given equations. What's that going to be? So how to solve for t in here? Solve for t. So we're going to isolate the t. In short, how we're going to remove the 4? Anyone? How are we going to remove the 4 in here?
Divide.
Divide. Very good, right? So we're going to divide both sides by 4 first. Let's use a different color. So hence, we got the following now. Log of t is equal to what? X over 4. But again, we just want t. If your log doesn't have a base, it's called a common logarithm. Automatic, what's the base?
10.
10. Very good, Addie. In short, what do we do to remove the log?
Inverse.
Inverse, which is 10 to the power. All right, so that's correct. You will raise it to the power 10. Okay, or 10 to the power. Okay, so what's going to happen? This and that's going to cancel by inverse log rule. Hence, we got the following now. T is equal to 10 x to the 4th power. That is just for t in terms of x. We're also going to use that one, solve for t, in terms of y. So let's color this blue. So again in here, we solve for t, and what do we do? What do we need to remove first? The 3 or the 2? Again, in here, we just want a t. So which one do we need to remove first? The 3 first or the 2 first? The 3. And how do we do that, guys? How do we remove the 3?
Subtract 3.
Subtract 3 both sides. Very good. So y minus 3 is equal to 2t. However, we just want the t. Okay? So how do we get rid of 2? Krish? How do we get rid of 2? Divide both sides by 2. Okay. So in that case, we have this equation now, right? So check. We have solved for t from those 2 given equations. So the first equation, t is 10 to the x over 4 power. And on the second equation, t is equal to y minus 3 all over 2. Now, what do we do? They're both t's. Step number 2. Jeremy, let's read this one.
Substitute t and solve for y.
Thank you, right? So you see that t on blue and t on the green. We're going to combine these two. Hence, we have what now? 10 to the x over 4 power is equal to y minus 3 all over 2. Why? Since this t and that t is the same, then by substitution, 10 to the x over 4 is equal to y minus 3 all over 2. Now, let's solve for y. So how do we solve for y in there, guys? What do we do?
Multiplied by 2.
Very good. Thank you. That's correct, Paula. Multiply both sides by 2 first, times 2, times 2. Hence, this is going to cancel out. Once again, guys, by PEMDAS rule, class, by PEMDAS rule, can we multiply this 2 times 10 to make it 20? Can we multiply 2 times 10 in here to make it 20 to the x over 4 power? Or no, we cannot do that. Answer, anyone? Hint. PEMDAS rule. What does PEMDAS rule say?
Parentheses.
Parentheses. There's no parentheses, right? Next. Exponent. So you have to raise it first to the x over 4 power before multiplying by 20. In short, you cannot multiply yet without getting the power first. So in short, just leave it as that. 2 times 10 to the x over 4 power. Questions? Okay, next. What do we do next? Add 3 both sides. Very good. Adding, right? So plus 3 on both sides. There it is. Hence, we got now the answer as follows, right? Y is equal to what? 2 times 10 to the x over 4 power plus 3. Questions, 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 questions.
And that's it? That's all you need to do to get the parametric?
Let's continue, all right? So that's a good question, Paul, all right? Are we done with that one, right? So yes, we have substituted t's and solved for y. Is that it? Okay, well, we'll see. Let's verify by Desmos graph, okay? So let's verify it by Desmos graph and see if we are already convinced that we got the answer right. So how do we do this? Capital letter X, the parametric function for x is equal to what again? 4 log of what? T. Okay. Yes, right. So that is our x. That's 4 log of t. And what do you notice with your x? What do you notice with your x value? Or the domain?
It's going to be positive.
It's going non-negative, right? It cannot be 0, neither can it be negative. So in short, in here we can say that the domain x value should always be what? Positive. Okay, x is greater than 0 because as you may notice, your x of t or 4 log t is always what? Greater than 0. Okay. What about your y? Let's put in here. Y parenthesis t is equal to what? A linear equation. Bless you. What is that? 3 plus 2t. Okay, that's a linear equation. Okay. Well, since that's linear, your y is all real numbers anyway. Okay. Now let's put in here the coordinate. What are your coordinates? The x of t is your domain, comma, the big Y of t is equal to your range, all right? Set of Y values. As you may notice in there, that is your t for such. So we can put in here what? Your t can be, can your t be negative? Let's see in here. Can your t be negative? 1 to 1, okay? Or 8 or 9, okay? So as you may notice in there, that in green will give us the value already, right? Now let's see, is that equal to our xy equation? And what's our xy equation? Let's put it in here. Y is equal to, what is that again? 2 times, what's that, 10 raised to the, what power? X over 4 power. Okay. What did we get? Plus 3. And let's verify if our xt, yt parametric equations is the same as this. Okay, let's see that one. That is your xy equation. This is your parametric equation. And as you may notice, this purple and this green, are they the same equation? Are they? They are. There. So that gives us, the confidence that, yes, this xy or Cartesian equation is similar to your x being that log and your y in terms of t being that linear equation. Now, if you want to put it in here as well as such, you can also put it in here as such, all right? Big X, parenthesis of A, excuse me. Okay, big Y, parenthesis of A as well. And seeing the movement of your A for such, right? So let's put it in here and see what the movement of this one is. Oops, there we go. I'm just changing this to just one direction movement and just seeing it as like how it's moving in there. Okay. Got it, everyone? What we did? Okay. So as you may notice, that is our direction of the parameter. As your t increases, it goes up towards that, what we call, what kind of equation is that one, by the way? Where your x is on the exponent. Anyone? Starts with letter E.
Exponential.
Exponential equation. Very good. That is correct. Any questions? Now, what if the form is this one instead? Okay, so the other question is this. What if we have this form instead and see how we can work on this one, all right? Numbers 19 and 22 and see how we can work on that, okay? Okay. What do you want us to work on? 19 or 22? It's your choice, guys. Paula, go ahead. 19 or 22?
19.
19. Let's try number 19. Thank you. And let's put it in here, okay? Number 19, we got the following. Oops. What is that? X of t is equal to what in here? 4 cos of t. And the other one, y of t is equal to, what's that? 5 sine t. Since, as you may notice in here, the difference between these two numbers is that in here, x and y are given in terms of sine and cosine. Okay, now what do we do if that will be the case? Let's read step number 1, okay? Nisse, can you see from there? No, not really. Too far.
Solve for sin t
And cosine t
cosine t
from?
from given equation.
Thank you. That is correct, right? So in here, we solve for, instead of just t, cosine of t. Okay, so what do we do? In order to solve for that, how do you get rid of the 4? Divide by 4. Very good. That is correct. And thank you. So just divide both sides by 4 in here. So hence, that'll be it. Cosine of t is equal to x over 4. That's correct. Now do the same in here. Solve for sine t. Divide by 5. There we go. That's correct. Divide by 5. All right. So this will cancel out. That's it, right? Sine of t is equal to y over 5. Now, since these two are not in terms of t's, but instead of sine and cosine, we have to use a certain type of identity. That involves sine and cosine. And what is that? Let's read step number 2. All right? Okay. Kamaria, let's go ahead. Read number 2.
Use Pythagorean identity to determine xy equation.
Thank you, right? And what is that Pythagorean identity that we're going to use? Sine squared. Very good, right? There we go. Sine squared t plus cosine squared t is equal to how much?
1.
1. Very good. Yeah, and then basically just use substitution for that, right? What's your sine squared of t? See this one? Okay, you just square it, right? Okay. So what's that? Y squared over 25. Okay. What about for cosine? I'm gonna use this, okay? See this one? We want square, so we're gonna square this too as well, right? So I'm gonna use that one for such. So this is what? X squared over 16 is equal to 1. So that will now be our equation for this. In that case, since this is x squared and y squared, I don't need to solve for y anymore. I just leave it as it is. Verify, this is one of what we call the conic sections. And let's see how it looks like, okay? So verify on our Desmos graph how this one looks like. Here we go. Let's plug it in here. First of all, what's your x of t? X of t is equal to, what's this again? 4 cosine of t. So that means your x is all real numbers, okay? Your y of t is equal to, what's this again? 5 sine of t. Oops. So as you may notice, your sine is also, oh, by the way, sorry. Your x, your cosine is from where? From -4 to 4 only, right? That's your domain, okay? What's the domain in here? Your x, as you may notice, if you graph this one, is 4 cosine of t. If you look at the red, what do you notice on the red? That the x value is from where to where? From -4 to 4. Okay? So that is your domain here, including -4 and 4. Okay? And for the range, if we look at the range, what's your range in here? The y values. That goes from -5 to +5. Very good, right? So -5 to +5. Including those two values, okay? Now, let's verify now how it looks like. So I'm going to put in here the following. What's that again? Big X of t. Oops. Parenthesis first. Big X of t, comma, big Y of t. Okay. So as you may notice in there, that one in green. Okay. And let me choose in here, so I can put that one as what? Say -5 to 5, for example, just to go, oops, -5 to 5, for example, just to give you the whole graph itself. By the way, if you are familiar with conic sections, what kind of conic section is this? It's called what we call an ellipse. Okay, it's like a circle but stretched. Okay, now let's look at the xy equation for that. What did we say? That is equal to what? X squared, okay, over 16 plus y squared over, what's this? 25 is equal to 1, right? Now what do you notice between the purple and the green? Are they the same, guys? Are they the same? Yes, they are. Okay. Now, since this is parametric, we have to know what's the direction of the movement in here. Is this counterclockwise or clockwise movement? And how does it look like? So let's put in here the following. I'm gonna copy this and put it in here. And instead of T's, I'm just gonna make them A's, right? A and A, okay? Just to give us an idea on what the direction of that parameter is, right? I'm gonna click on the slider A and then change this one to this one direction, okay? See how it's moving, guys? You good? Okay, so it starts where? It starts in here and went counterclockwise direction. Okay, as you may notice in there, or such. Okay. And as you may notice as well, what's the domain for this? What's the domain for this graph? Guys, look at the domain. What is the x value? Very good, negative 4 to 4, right? And you can verify it from here. According to our domain, that's negative 4 to 4, based from this, okay? So let's verify in here. Negative 4 less than or equal to x less than or equal to 4. That's the domain. Okay. What's the range for this one? What did we say the range is? Negative 5 to 5. So let's verify as well. Negative 5. By the way, I cannot put in here the interval notation, but the inequality notation we can verify it from here, right? Y less than or equal to 5 as well, right? And as you may notice, that verifies that the domain is this, which is negative 4 to 4, and the range is that, negative 5 to 5. Questions, guys, with what we did? Okay, last one in here. Let's read in here what we're gonna do, all right? Inisi, go ahead. How to? I don't know how to pronounce that. Parameterize, right? Parameterize. Okay, but I tried, right? Okay. A given
x, y
equation. Thank you, right? So basically, this is the reverse of this. What if you are given this? How are you gonna get those two? Okay, so you are given the xy equation now. How are you gonna get the parameters? Xt and yt. Okay, let's try this out. Number 36. Let's try in here number 36 and see what we can do with that. Okay, let's read the equation in here. Let's read the instruction in here for number 36. Okay. Prish, go ahead, please. For the following exercises.
Write parametric equations for each Cartesian equation by using xt equals a cosine t and yt equals b sine t. Identify.
Thank you. Okay, this is what? X squared plus y squared is equal to 16. So let's put it in here for our last problem. X squared plus y squared is equal to 16. So that's your xy equation, what we call our Cartesian equation as well. What do we need to do? number 1. Paula, go ahead please.
Solve for sine t and cosine t from given equation.
Thank you. Okay, so again, your given equation are as follows. Your x of t is given to be what? It says there, a cosine t. Good. And your y of t is given to be what? B sine of t. Okay. We are basing this one from the given. So it already says in here, the given xt and yt are of this core, and here it is. Xt, and that is your y. Right? Okay, so we're going to base that one from there. Now what do we do in here? Solve for sine t and cosine t from given equation. So in here, for x, how to solve for cosine t? We just did this, right? What do we do?
Divide.
Divide both sides by what? By a. Very good, right? So in here, divide both sides by a. So this will cancel out. Hence, we got what? Cosine t is equal to what? X over a. Okay. Now do the same in here. Solve for sine t. What do we do to solve for that sine t? How do you get rid of the b? Very good, Amaya, right? Divide both sides by b. Very good. So cancel this. Hence, sine t is equal to what? Y over b. Okay, so we got cosine t and sine t already in terms of what? Cosine t as x over a and sine t is y over a. Where did we get this one from? Well, you notice from the given, right? Where it says what the format is. Step number 2. What do we do? Okay. Eunice, can you see it from here? Identity.
And solve for A and B.
Thank you. All right. So, what's our Pythagorean identity again?
Sin squared t
Plus
cosine t squared.
equals.
Cosine squared t plus
Equals.
1
Very
equals
good.
1.
Okay. So that means this. Okay. So in here, verifying everything. You know what? Let me use blue in here, right? Sine squared t plus cosine squared t is equal to 1. Okay. What's your sine t? What you're gonna do with this? Square it. Okay. So if I square this, I'm gonna square both in here. Okay. So we got what? Y squared over b squared plus, what's your cosine squared t? Square both sides as well, right? If I square this, I'm also gonna square this. X squared plus, what's this? B squared. Is equal to what? Okay? So again, we get the following. Sine squared t is equal to what? Y squared over b squared. Okay. Plus cosine squared t is equal to what? X squared over a squared. Is that equal to 1? Okay. However, how do I solve for a and b in there? Well, look in here. It says in here x squared plus y squared is equal to 16. So how are you going to make this 16? Times 16 both sides. Okay, very good. That is correct. So that's what I'm going to do in here. Okay, and with that being said, what I have now are the following. You know what? I think it's better to divide this by 16 instead of multiplying it by 16, right? So this is what I'm going to do, right? It's just basically the same, but here's what I'm going to do. Since that is equal to 1, what I'm going to do in here is just to divide everything in here by 16. Okay? Right? Because with that being said, oops, it's easier to see it in there like such. Because if this is 1, you divide everything here by 16, and this will now be equal to 1. x squared over, what's 16 squared? Oh, what's 16, what's the perfect square of 16?
4.
4 squared plus y squared over 16 is a perfect square of 4 as well is equal to 1. Okay. So what do you notice in there? What is your a equal to?
4.
4. And what is your b equal to? 4 as well. Although in there, you can also use your Math 171 skill of what? Elimination method or substitution method in order to solve for A and B. But either of those, either use this method, substitution method or elimination method, you're gonna get your A and B anyway, okay? So, what's the last one in here? Step number 3. Let's read this one in here. Kamaria, go ahead please.
Rewrite x, t, and y, t using a and b values.
Okay, so what's your xt again? So rewriting that one. What's your x of t then? What's your a again? 4. Right? So that's 4 cosine t. And what's your y? That's b sine t. And what's your b again? 4 sine of t. Okay. And lastly, we can verify if that answer is correct by going back in here and seeing it on our decimals. Okay, so here it is. What's our x of t? 4 cosine t. Okay, so what's the domain? What's the domain for your x value in here? -4 to 4? Correct. Okay, so that's your x. What's the range? Verify in here, what's the range? Y of t is equal to 4 sine of t. So what's the range? -4 to 4 as well. Okay. So basically, domain and range are both -4 to 4. Let's verify the graph. X of t, comma, y of t. And let's see what we are getting. Okay, let's put in here what? -4 to 4. What kind of shape is it, guys?
A circle?
Circle. Thank you. Right. Now let's verify. Is our given correct? What is our given, by the way? X squared over 4, right? Oh, well, yeah, sorry. X squared is the given. Plus y squared is equal to what? 16. Right? Are they the same? Yes, they are the same. Okay. And just to see the direction of the parameter, that's why basically we are seeing the direction of the parameter. That's basically is the primary reason why we're doing the parameter in here in terms of t, sometimes called the time. Let's verify this. Just change this one to a and see how it looks like. Okay. There we go. And see this one again, just one direction. And seeing it in terms of, okay, so there we go. And seeing its animation. See how it moves? So it starts at the x-axis and it goes that direction. Questions, guys? So as you may notice, the direction is this. Oops. Counter-clockwise direction. Starting with what? The 0 radians. So it starts in here, went in there, and goes back. Okay? So that's the direction of this parametric equation changed into its xy equation. Okay? Thank you.